Hi everyone, thanks for coming. My name is Niklas Therning. I'm the founder of the RoboVM project and head geek at 3D Mobile. I'm here today to introduce you to RoboVM and show you how it can be used to develop native iOS apps using Java. Now, before I start to talk about RoboVM, I'm going to just give a quick background on why I started this project. Mobile app developers of today face one big problem. This. We have a number of different platforms to target if we want to cover the whole market. Even if we just choose Android and iOS, which is what most developers do anyway, to cover maybe 95% of the market or so, we still have problems because there are different APIs, different tools, even different programming language on those two platforms. So we have to basically develop two separate apps, one for Android, one for iOS. We have two separate code bases and maybe even two separate teams that work on these apps. So building apps for mobile platforms is expensive. And this insanity is what made me start the RoboVM project. So it would be cool, right, to be able to use Java on both platforms, to be able to reuse code between the two platforms. Now, back in 2010, we started to build Android and iOS apps for the product that I was working on back then. We evaluated the cross-platform tools that were available at that time, and most of them, and this is still true today, 4 years later, most of them are based on web technologies. So basically, you build an app using web technologies, HTML5, JavaScript, CSS. You package it and distribute it on the Google Play Store or on Apple's App Store. However, we wanted to build apps that looked native to the platform using the native APIs so that users would feel at home in our app. So in the end, we went with the native tools for the different platforms, and we ended up with two code bases to maintain. So let's just talk a little bit about the lessons we learned from the iOS app that we developed. As I said, we used the native tools, which means Apple's iOS tools. And this is actually the way that most apps are developed for iOS today. So Apple's tools means the Xcode IDE and the Objective-C programming language. By the way, has anyone done any iOS development in here? Okay. Using Xcode and Objective-C, right? How many of you? Yeah. And how many of you like to use those tools? Okay. A few of you. Okay, great. Well, I know that developers can be quite passionate about the technologies that you use, so please don't hate me for what I'm about to say about Objective-C in the next few slides. So while I don't really fancy Xcode that much, the biggest problem I see with iOS development is actually the Objective-C programming language. So let's talk about that for a little bit. Whoops. So Objective-C is a superset of C. So any piece of valid C code is also a valid Objective-C piece of code. On top of C, Objective-C adds a thin layer of object orientation influenced by Smalltalk. Here's in Objective-C, objects exchange messages rather than call methods on each other. So this Java method call would look like this in Objective-C, and this is called passing a message to ob. And except for those weird brackets around that statement, it looks pretty similar, right? But under the hood, it's very different because message passing in Objective-C is the target of this message is actually resolved at runtime. So the language is extremely dynamic, and you can do a lot of funky stuff with Objective-C at runtime. So, for instance, you can create classes on the fly. You can change methods on existing classes at runtime. You can even do that on system classes, on the classes that Apple provides in their APIs. So, what are the problems with the Objective-C programming language? Well, the first problem, as I see it, is its C heritage. C is a very nice language. I use it a lot in the internals of RoboVM, but it's very low level. So, and for most apps, you don't need to be able to explicitly tell how things are laid out in memory, and yeah. So, using C, it's quite simple to make code that crashes, that has security problems, and so on. And so, in my opinion, C is not a language that's suitable for application development. There are other things like building a Linux kernel, for instance, that is very suitable for use case for C. But in mobile app development, you don't really need the power that you get from C, at least not for the whole app. If you have a routine that's very time critical, you can do that in C and call that from your higher level language. But yeah, so yeah, and I should also say that in Objective-C, yeah, most apps don't need C, but in Objective-C, C is not optional. You always have it there, and you're always only a null dereference away from a crash. So if you have a pointer like this, and then you try to dereference that null pointer later on, this will result in a crash. Your app will crash. You won't get a null pointer exception as you would in Java or in C#. It's a hard crash, so if you're lucky, you can get out a crash log from your device that makes any sense, and track down the cause of the problem, but yeah. Objective-C doesn't come with a garbage collector. You have to manually take care of memory in your Objective-C app. Now, the Cocoa Touch APIs, the APIs that Apple provides on iOS, are using reference counting. So when you start to use an object, you have to call retain on it, and then when you're finished with the object, you call release. Now, in recent versions of the Objective-C or in Xcode, Apple added what they call ARC, which is a feature. It stands for automatic reference counting. So the compiler, the Objective-C compiler, will actually insert the retain and release calls for you, so you don't have to bother. So this is a good thing, of course. But you can still run into problems that any reference counting system suffers from, such as retain cycles, for instance, where two objects reference each other, and none of them can be deallocated because the reference count will never come down to 0. Another thing that annoys me with Objective-C, which is a feature to some Objective-C programmers, I think, is that you can send messages to the nil reference. Nil is just another name for null. I don't know why they choose to call it nil. So you can pass a message to nil. You won't get a crash. In Java, you would get a null pointer exception immediately. The same for C#. But in Objective-C, the execution just happily continues. And in my opinion, this is a disaster waiting to happen. Later on, if you had a nil reference by mistake, and later on you get another problem that is related to this, it's really hard to backtrack and find the original cause of that problem and to fix it. So, if you hate me now because I'm talking bad about Objective-C, please consider this statement, and you'll see that it's actually good that I complain about Objective-C, right? My point is here that, my point here is that you should use a higher level language for application development, and Java and other JVM languages are more suitable because of the safety and memory management features of the underlying Java platform. So let's talk a little bit about RoboVM and see how it improves things for mobile app development. So the RoboVM project, the goal is to bring Java to iOS and also other JVM languages. So far, it's possible to use Scala, Clojure. There's also one guy, he managed to get Kotlin to work. In theory, you should be able to use any JVM languages, any JVM language that compiles down to Java bytecode. I started this back in 2010. It was open sourced last year in January. It's available on GitHub. We're using liberal licenses, so you can use it to develop closed source apps. It's available on RoboVM.com. Go there for more info, and if you're interested in project updates, make sure you follow RoboVM on Twitter. So, what do you need to use RoboVM? First of all, you'll need a Mac. Running OS 10, 10.9, you'll need Xcode. You're not going to use Xcode, but you'll need it installed. Sometimes you may have to open it, but... and you'll need Oracle's Java 7 JRE. So you can't use Apple's Java 6 JVM. So let's talk a little bit about the features of RoboVM. RoboVM compiles bytecode into machine code ahead of time. So normally when you have a JVM like Oracle's, your bytecode is interpreted or just-in-time compiled as the application is executing. On iOS, however, we're not allowed to do this because Apple has put some restrictions into iOS that prevents us from doing this. So instead we have to ahead-of-time compile, which means that at compile time on your developer machine, we take the class files, transform them into machine code. So this is what it looks like. We have a main class. Something has generated a .class file containing bytecode. It could be Java C, Eclipse, whatever, NetBeans, whatever. This is fed through the RoboVM compiler, and out comes an object file containing machine code for the CPU that we're currently targeting. Right now we support x86 and ARM. So this object file, if you're used to C, C++, Objective-C, for instance, you may have seen object files before. It's a very similar kind of file. So the runtime clauses are based on Android's runtime. So all of those packages that you're used to see in any JRE, like java.lang, java.util, etc., all of those come from Android. And these clauses are processed in the same way. We take the class files, feed them through the compiler, and out comes an object file, one for each Java class file. RoboVM also supports the standard Java native interface. So JNI is a standard developed by Oracle or Sun or whatever. It's used to interface with native code from Java. So normally it's based on dynamic linking. So you take your native code, you package it into a dynamic library, And then at runtime, you would use system.load_library to load your dynamic library. And the JVM would bind functions in your dynamic library to native methods in your Java code. Now on iOS, the problem is that Apple doesn't allow us to do this. So they don't allow us to ship any dynamic libraries with our iOS app. So instead, we have to rely on static linking. So it's the same JNI code, but instead of packaging things in a dynamic library, you would package it into a static library. So here's what it looks like. This is what happens after we've compiled all of the class files into object files. We have a bunch of object files. We feed these through the standard linker that comes with Xcode. And if we have any custom JNI code, we've made a static library out of it, and then we link that in at the same time. And all of this takes place on the developer machine. And out comes our executable that we can package into an app. So RoboVM also has a built-in framework to interface with native code, which is called Bro. This is the Swedish word for bridge. So using Bro, you can call native code without using any JNI. Typically, this is used to call into system functions in system libraries. So you don't have to run with this. You don't have to write any native code if you need to call into a system function. So here's a very simple example. There's a function in the libc system library called abs. It takes an integer, returns the positive of that integer. This is how we would bind this using Bro in Java. So here we have a native method called abs, and we annotate this with the bridge annotation here. And then on the class level, we specify that we want to bind bridge methods in this Java class to the libc library. And then in the static initializer here, we call bro.bind. So this will open the libc dynamic library, which iOS provides, and then bind any bridge methods here in the Java code to the corresponding C function. So then when we run this main method here at runtime, it will hopefully output 100 on the console. So using Bro, we can not only call functions, we can also map C structures, we can map C enums, we can define callbacks in Java code that we can give to native to a native function, and then the native code can call into Java at a later stage. So this Bro is used to has been used to build an Objective-C, Java to Objective-C bridge. And on top of this, we're currently working on binding the CocoaTouch APIs. So the CocoaTouch APIs are the APIs that Apple provides on iOS. So there are about 50 frameworks. A framework is like a package. Each of these frameworks have different functionality. There are frameworks for building UIs. That's the UI kit here. And then there's a lot of other stuff here, that drawing, graphics, playing media, interfacing with the hardware, like using Bluetooth, GPS. Anything and everything that you can do on an iPhone is accessible through the CocoaTouch APIs. So this is still a work in progress, but once we've finished this, you will be able to do anything that you could have done if you had chosen Objective-C for your app. You can do that from your Java app. So RoboVM also integrates with popular Java tools. So the idea is that you, as a Java developer, you should not have to relearn a lot of stuff. You don't have to learn Xcode. You don't have to learn Objective-C. You may have to learn the CocoaTouch APIs, but it's supposed to dramatically lower the learning curve. So currently we have an Eclipse plugin. There's a Maven plugin that we develop. The community has provided a Gradle plugin. Then there's a Scala build tool plugin, and there's also a LineEM plugin for Clojure's build tool. So now I'm going to show you a little demo. The first thing we're going to do is to use the command line tools to compile a very simple Java app and run that on the console. So first of all, we're going to just create a Java source file. So this will just create a main method here, and yeah, it will print out hello world on the console. Yeah. So now we have our Java file. We will run this through the Java-C compiler, giving us a class file. And then, yeah, we run it through the Java command, and out it prints. This is using the Java interpreter, of course. It prints Java. It prints hello world as expected. Now let's run this through RoboVM. So first of all, we're going to download RoboVM. Then we will extract it. So, and then we'll call the RoboVM script. And the command here looks very similar to the Java command before. We have a class path argument here. We specify the main class at the end here. We also give it the run argument here, which means that after you've built the executable for us, just launch it directly. So let's see what happens. So it starts to compile classes. As we can see here, it starts by compiling the hello world class. RoboVM works by it starts at the main class. It compiles that, and during the compilation, it will record all the dependencies of that class, and then it will continue by compiling the dependencies of the main class, and then it will continue with the dependencies of the dependencies, and so on. So as you can see here, hello world is the first class. You can just ignore these warnings. Then it will continue with stuff in java.io that are needed for our main class here. From here we can also see that we're actually building an executable for macOS 10 here. So it's not RoboVM, apart from iOS, it can also build executables for macOS 10 and Linux. So let's continue and see what happens. As you can see, it starts to compile a lot of stuff here. There's and all of these classes that we see here comes from the Android runtime. So let's skip ahead a bit. So we've now compiled around 1,400 classes that are needed by our Hello World program. The final thing that happens is that it links these into an executable using, this is the linker that comes with Xcode, or a front end for the linker. And then when the linker is done, it will launch the program and print out Hello World here on the console. So there was a lot of classes here that had to be compiled, and it takes a lot of time. So to make this a lot quicker, RoboVM will cache the result of all of these compilations. So this is a one-time thing only that you saw here. This is what will happen the first time you install RoboVM, or maybe when you install a new version of RoboVM, you will also have to do this. But the cache will keep the object files cached away. So unless something changes, it can use the cached version. So let's see what happens if we run the same command again. So this time it's not compiling anything, it's just doing the linking, and it's a lot quicker. Finally, let's have a look at what happens when we oops. Let's see what happens if we change the Java file. We will remove some characters, and then we launch the same command again. We have to javac the class, the source file first, of course. We run the same, and you'll see here that it compiled hello world again, but none of the other classes that were needed. And then it prints out hello world without the characters that we removed, of course. All right. So, yeah, let's do another demo. This time I'm going to show you the Eclipse plugin. Not that many of you are probably going to use the command line anyway. So if you want to use the Eclipse plugin, just head to Help, Eclipse Marketplace, and then search for RoboVM. And it's right there on the Eclipse Marketplace. Just make sure you have Xcode installed and you are running Eclipse in a Java 7 JRE, and then it should work. So let's create a new RoboVM iOS project. We have to fill in a few things here, so let's do that. We have to obviously specify a project name, and then down here we have to specify the name of the main class that our app will run. This is the app name as it will be shown on the springboard on your iOS device next to the icon. And then we also have to specify an app ID, which is usually done like this. All right, so let's have a look at what the Eclipse plugin created for us. First of all, it looks pretty much like a normal Java project in Eclipse, except that we have this RoboVM runtime library up here. So instead of having Oracle's runtime library that you would have in a normal Java project, instead we have the RoboVM runtime library, which contains the classes from Android, java.lang, java.util, etc. We also have this CocoaTouch library here, which contains the CocoaTouch bindings. And then the plugin created a bunch of files for us. This is a property file that just lists the stuff that we specified in the new project wizard. Then it created this RoboVM.xml file, which is configuration for the compiler. And as you can see here, we can use the properties from the properties file using this dollar curly bracket notation. So if we would want to link in a static library, for instance, this is where we would have to go in and add an element to specify the static library. And the last file that the plugin created for us is this info.plist.xml file. This is the info.plist file is something that any iOS app needs to have. As you can see, we can use the same properties here. This file just contains a bunch of metadata for the app that iOS will read, like the name of the app, the name of the executable. Maybe you can use it to specify the icons, the supported interface orientations of your app, and a lot of other stuff. So, let's see. Next thing we're going to do is to create that main class that we specified. So this is going to subclass UI application delegate adapter. We'll implement a main method like this that just calls UI application.main. And then we will implement a single method from the UI application delegate interface that is called did_finish_launching. So what happens here is that this UI application.main call here will call into the UIKit framework on the Objective-C side. And UI application main in UIKit launches the UI thread and sets up the app. And then it will start to call lifecycle methods on our UI application delegate. So there are a bunch of lifecycle methods that you can implement. We are only implementing did_finish_launching here. So this will be called just after our app has started. And this is where we can set up a UI and initiate things. So let's add some UI components to this. We're going to start with creating a UI window. This is a top-level container, and we're going to give it the same size as the entire screen, and we'll give it a light gray background color like this. And then we have to make it the key window and make it visible. The next thing we're going to do is to add a label. Oops, sorry. We have added a label here, UI label, and then we just create the label here, give it some a position on screen and some bounds. We set the text, and then we have to add it to the window like this. So let's launch this in the iOS simulator. So just control-click the project or right-click if you have a right mouse button. Run as iOS simulator app. This time we're going to simulate an iPhone. We could have chosen to simulate the iPad. Or we could have chosen iOS device app here if we wanted to try this on an actual device. So let's see what happens. The iOS simulator pops up. You can see here all the time what happens with the compiler down here in the RoboVM console. It's the same output that you saw in the command when we use the command line tools. So yeah, it outputs hello world as expected. Okay, so let's fancy up that label a little bit. I'm going to make it centered, set the background color. Oh, actually, it's a transparent background color. And we'll give it a slightly larger font size, like this. We're going to launch it again in the simulator. And there it is, a lot nicer. So let's add a button as well. So UI button is what we would use. And this is how we create a button. And then we set the frame, which is, we specify the location and size on screen. And we set a title for the button for the normal UI control state, like this. And finally, we have to add it to the window. So let's run again on the simulator and see what it looks like. Okay, so now we have a button that we can click, but nothing happens. So the final thing I'm going to do is to just, make something happen when we click that button. So we'll add a on-touch up inside listener. Like this. And then we'll set the label text like that. Let's see what happens when we launch it in the simulator. Yeah, so it works. So if we want some proof that it actually works on a real device, I have the same app running here on my phone. I doubt that any of you can see that it's real, so when I touch here. If you want to check it out later on, you can come up and I'll demonstrate it for you, just as a proof that it works. So, are there any limitations in RoboVM? First of all, we don't support runtime bytecode loading. So, third-party stuff, or if you do it yourself, things that create a custom class loader, generate some bytecode at runtime, and tries to load that bytecode using the custom class loader, that will not work with RoboVM. So, all the bytecode that your app needs will have to be available at compile time. As I mentioned before, there's no dynamic JNI, so you have to use static JNI instead. There's no debugger yet. There's going to be a debugger at some time, but not at this time. And since we're using the Android runtime class library, where you're roughly limited to the Java 6 APIs, you can still use Java 7, the new Java 7 language features like try with resources and switch on string, etc. But you're limited to the Java 6 APIs. And you'll need a Mac to build for iOS, at least. So, what's the current status of RoboVM? It's usable. Sorry. It's usable. I used to say that it's not production ready on the website, but I removed that because people are using it. They are deploying stuff to App Store, and they ask me, what is it that... What do you mean with not production ready? It's working really nice for me. So it's really up to you if you want to. You have to test your code, of course, and make sure it works. But depending on what you want to do, it can be production ready. So the plan is to make a 1.0 release sometime later this year, and then I will probably start to call it stable. So there are already probably more than 50 apps in the App Store. Here are some of them. These are all games that I'm showing you right here. I would say that almost all of them are games. They have been built with the help of the libgdx Java game development framework. So using libgdx, you can develop a single code base and then use that to target Android, BlackBerry, the desktop, iOS using RoboVM. So libgdx comes with a iOS backend that has been based on RoboVM. So if you're into game development and you want to do it with Java, you should definitely check out libgdx. So what does the future hold? We need to document stuff. It's very poorly documented at the moment. This is something that we have to address before we release a 1.0, so there should be better documentation pretty soon. Oops. There's no debugging, as I mentioned. We have to address that as well. We need to complete the Cocoa Touch bindings, and This will also be done for the 1.0 release. It would have been cool if you could use this to develop iOS apps without a Mac, without Mac hardware. You can probably make it work in a virtual machine, but yeah, you'll need a Mac for now for iOS development. As I said before, we're using Android class libraries, which are a bit dated. So it would be nice to be able to transition to the OpenJDK classes instead, and get all of the Java 7 and Java 8 APIs. And then in Java 8, they introduced a couple of new language features that would, in particular, the lambdas. That would have been really cool to have in RoboVM as well. And then finally, finally, we would like to have some kind of integration with the interface builder that comes with Xcode. So with the interface builder, you can graphically draw UIs and bind that into your code. It would be cool if you could bind like a button click to your Java method. Yeah, so that kind of integration would have been cool. All right, so thank you for listening. I think we have some minutes for questions, if there are any.
Hello. How do you manage when you're using a library, Java library that is making some forenames, so which is using another classes which is not in my, which I don't have the source code?
Yeah, the question is whether if you can use this if you don't have the source code for the third-party libraries and stuff that you're using, right? Yeah, yeah, no problem, because we don't process any Java at all. You use, it takes the Java bytecode, which is the result of the Java C compiler or the Eclipse compiler or whatever. So if you buy a third-party library, for instance, that you just have a jar file, for instance, it will work. If it works, I can't promise that it will work because there might be dependencies in that jar file that we don't provide in RoboVM, of course. But the general rule would be that if it works on Android and if it doesn't use any of Android's UI classes or anything in any sub-package to Android dot something, it should work. Yep. So.
Hi, RoboVM is just wonderful, so thanks for your work. Can you tell us about the performances we can expect?
The performance? Well, I've done some performance tests, and it's hard to compare because on iOS there's nothing to compare to really. But when I run it on macOS 10 and Linux, it's roughly half the speed of Hotspot. So I would say that, and if I compare it to other JVMs, open source JVMs, it's very competitive. So you can imagine that Hotspot, they put, I don't know, centuries into developing Hotspot. There's been a team of people working on it for, I don't know, 20 years or so. So it's very, very good. And being half as fast as Hotspot, I regard as pretty good, but there's still room for improvements to that. So, but yeah, so I would say roughly half of Hotspot, half of Oracle's JVM. Yeah.
Are you familiar with a project called J2 Obj-C? I was wondering how you would compare RoboVM with it.
Yeah, yeah, I'm very familiar with J2 Obj-C. It's a Google project, or a Google guy at least, that's developed it. I think it solves a different use case because it takes Java code. It doesn't process bytecode. So if you have an app Yeah, basically you can use it to share code between your Android and iOS app, but you have to have the Java code, of course, and it's probably more used if you want to develop quite a lot of your app using Objective-C, and then stuff like talking to the backend, for instance, networking. You can share that between the two platforms, but you make the UI in Objective-C, for instance. Yeah. Okay. Thank you.